Right, probability. In this example, we're going to look at creating a probability function and then using that information to help find the probability that exactly one of these two captured corn rakes is capable of mating. So before getting to that, the process for going through these problems, I always just read through it one time without really writing anything down, just trying to get my mind wrapped around what they're giving me, and then I'll start building things up. So we have the census revealed that 12 corn rakes inhabit Scotland. 2 of these Scottish corn rakes are captured for mating purposes. We're going to let X be the number of these captured corn rakes that are capable of mating. So that's going to be an important clue as we build up that probability function. And then if exactly 4 of the 12 Scottish corn rakes are infertile and unable to mate, we're going to find that probability function. So that 4 of the 12, that's going to be important in terms of creating the probabilities here very shortly. And then we want to calculate the probability exactly 1 of the 2 captured corn rakes is capable of mating. So one way to approach this, just to get our mind wrapped around it, is with a tree diagram. So let's forget about the numbers in terms of 12, the 4. Let's just focus on the 2. So the 2 of these were captured for mating purposes, and the X is the number of these that are capable of mating. So what I'm going to do is just build a little tree diagram here. And let's pretend that this first branch represents the first one that's captured. And that first one that's captured, based on the fact that not all are capable of mating, would fall into one of 2 categories. Either you capture a first one that can mate, or you capture a first one that is infertile. Okay, so then the second one, we have branches coming off of each of the first, because we don't know what the first is going to be, but whichever it ends up being, we could still have those same 2 categories for the second one being captured. So you're either able to mate or you're infertile. And with this tree diagram, the reason I'm putting this together is now I can start at the top here at the so-called the root of the tree, and I can work my way down the branches and get an idea what the sample space is for this scenario. So I could either have 2 that are able to mate coming down this branch right here, or I could have the first one able to mate, the second one does not mate, so that would be this branch here. The next branch, we would start out with an infertile one on the first choice, and then get a second one that was able to mate. And then the last one is that both are infertile. Okay, so if there were equal probabilities of each of these happening, like say you're flipping a coin, you got heads, tails, the probabilities, we would just start multiplying some halves by each other. Well, here they gave us a different set of information about these probabilities that we can use. And they tell me that exactly 4 of the 12 are infertile and unable to mate. So if I'm just looking for the probability of being able to mate, 4 are infertile, so the probability of being able to mate, there should be 8 out of the 12. So you get 8/12, and you can reduce this down to 2/3 here. So now with that information, I can start building up my probability distribution for X, and we'll come back to this tree diagram to help us finish this out. But for the probability for X equals little x, we have to think about all the possibilities for that little x. So building our little probability function here in a table format, we'll have the x, and then we'll have the probability that x equals x. So the first we could have, and remember what the x is actually equaling to here, x is going to be the number of these captured corn rakes that are capable of mating. So the ones that are actually capable of mating. And we're just going to suppose that 2 of these are being captured overall. So The number that could mate out of these two, well, it could be 0. We do have that case where they're both infertile from our tree diagram. We also have the case where there could be 1 that's able to mate. As you look here, there's actually 2 of those scenarios, and we'll have to account for those individually before we put them together into this final chart here. And then there could be both of them. We get lucky, both of them are able to mate, and that would be it. Either you get 0, 1, or 2 that are able to mate. So now let's start figuring out these probabilities for the 0 case, the 1 case, the 2 case. And again, this is where the tree diagram can be really helpful, because I know the probability to mate is 2/3. That means that the probability of picking an infertile one is going to be 1/3, or 4 out of the 12, which would reduce down to 1/3. So then on these little tree diagram branches, this is why I love the tree diagram, I can just start putting these little probabilities here. Okay, we got a 2/3 chance of getting a mating one, a 1/3 chance over here getting infertile. I got a 2/3 chance here. We got a 1/3 chance there. I got a 2/3 chance here. I got a 1/3 chance there. And what we can now do with this MM case, we want to get a mating and a mating. Well, you're just able to multiply those two together, the 2/3 times the 2/3, and get the final probability for this branch. So 2/3 times 2/3 is going to be 4/9. And then for the first being mating, the second infertile, 2/3 times 1/3, you just multiply down the branches, you're going to get 2 out of 9. Infertile first, then a mating, multiply down, you also get 2 out of 9. And multiply down that last branch when both are infertile, you get 1 out of 9. And notice that all of these here add up. If you add up all the numerators, you're still getting 9 out of 9, which is what you want. You want your probabilities to add up to 1. So coming down to the actual table now that we're putting together for our distribution function for x, the probability of 0 being capable of mating means that they're both infertile. We saw that that was a 1/9. For the probability of 1, we have to actually look at both of these outcomes here, the 2/9 and the 2/9. And the idea with this is an OR situation where you could either have the first one being mating capable, or you could have the second one being mating capable. So you got to add those 2/9 and 2/9 together, and you would get 4/9 here. And then for the both being able to mate, that would be the 4/9 here. So this would be your probability function for this particular scenario for that random variable x. And then what they wanted was the probability that exactly one of the two is capable of mating. So we want the probability of x equals 1. And in this case, based off our table we created, you get 4 out of 9. So I hope that helps if you're looking for an example of this type of problem. And thank you for watching.